Module 3, we're going to look closely at the material editor and see how we can simulate just about any material on Earth by controlling all the visual properties a material possesses. Materials are my personal favorite area of 3D to work with because to me it's the point at which objects come to life, and I really just enjoy working with all the great tools that VRay provides and seeing all the wonderful effects that just a few short years ago weren't even possible. While materials play a major role in the visual aesthetics of a scene, they have just as great an impact on rendering times. In this lesson, you'll learn how to get the most out of material effects such as blurry effects, material characteristics such as refractions, and we'll do this without bringing your computer to a grinding halt. At the end of the module, I'll point out some great resources for free materials, which will give you access to hundreds of different material types. This module of instruction assumes that the viewer possesses a fundamental level of knowledge of the material editor as well as UVW mapping and the critical map types and map channels. Therefore, we won't spend time covering any of the basic material editor interface elements or any other basic mapping techniques. Okay, so when you open the material editor, you should see nothing different unless you have adjusted your default Max startup interface to show VRay materials by default. And if you haven't enabled VRay as your render engine through the Assign Renderer rollout in the Render Scene dialog box, you're not going to see all the VRay material types available, just these here, which won't do you any good by themselves. As a side note, when VRay is not the selected renderer, you will see a simple black sample slot object rather than the correct object appearance. So I'm going to load a scene with VRay already selected as the render engine, and if you want to follow along, open up the file called Material Test 01. When I open the material editor, this time you'll see all the different VRay material types available. We're going to focus on one for the majority of this module, and that would be the VRay material. And near the end of the module, we'll take a quick look at what some of the other material types can be used for. A couple of common questions that pop up on VRay forums are, do you have to use VRay materials if you're using VRay, and is it better to use VRay materials? Well, the answer to the first question is no, you do not have to use VRay materials. Other material types will usually render just fine, but the answer to question 2 is usually. VRay materials are optimized for faster and more efficient handling of GI than other material types are. And let's see this. In this scene, I have scattered a torus knot around the surface of a box. In the material editor, you can see that I have two sample slots with what appears to be similar materials. In this sample slot, I have a VRay material loaded, and in this slot, I've loaded a standard material with the exact same color and the same basic default properties. There is no reflection, no refraction, translucency in either, so they will appear to be the same when rendered. As you can see by the white triangles in the corners of the sample slot, this material is applied to both objects in my scene. I'll render the scene as is, and let's see how long it takes for the scene to render with VRay materials applied and then with standard materials applied. So I'll pause. So with VRay materials, this scene takes 23 seconds to render. Now let's try standard materials, and I'll pause. And as you can see, it takes 25 seconds to render the same scene. Now, 2 seconds may not seem to be much, but this is still 10% of the overall render time, and this 10% can easily jump to 20 or 25%, depending on the type of scene you're using. And when your scenes take several hours to render, this can mean a great deal of extra time. Now, for the second question I posed, should you use VRay materials, I answer this question usually. Most of the time, you should in fact use VRay materials throughout your scene, but there are some situations when you might be better off doing otherwise. Let's see one of them. To demonstrate this, I'm going to change both materials so that they reflect a small amount of specular highlight. For the standard material, this simply means increasing the specular level and then adjusting the glossiness to provide the particular type of highlight that I'm looking for. Now, to create the same specular highlight with VRay, I need to add a small amount of reflection, just enough so that it's not noticeable throughout the entire material, but rather only on the highlights. I'm going to use a value of 5, and I'm going to make a quick adjustment to the highlight glossiness, which I'll discuss in detail in just a moment. But right now I just want to quickly get a similar appearance to each material, and this will do just fine. Now, as an additional note, the only illumination in the scene is skylight, and in order to actually see or reflect specular highlights, you need to have a more acute light source. And in this scene, I actually have an omni light which is turned off, so at this point I need to turn this omni light back on so that I can actually see specular highlights or blurry reflections in this next demonstration. So I'll apply the VRay material to the torus knots and render the scene again. And when I do, you'll see the rendering time jump dramatically. And this is a function of using blurry reflections. And now I'll apply the standard material to the same torus knots and render the scene again. And as you can see, the rendering time was not quite so long using specular highlights with standard materials as opposed to using blurry reflections with VRay materials. So this is a case when using a non-VRay material might be beneficial. To create the same highlight with the standard material, the material did not need to reflect its surrounding environment and did not need to blur the reflection like the VRay material was required. And if you don't know what I mean by this, don't worry, you will in a moment. This was just a simple demonstration comparing the practicality of using VRay materials versus other material types. Before going any further, I want to point out a fantastic feature that allows you to convert all the materials in your scene to VRay materials in just a few seconds. To do this, simply right-click inside the active viewport and select VRay Scene Converter. When you do, a message appears saying all scene materials and ray trace shadows will be converted to VRay materials and shadows. Are you sure? Select yes, and voila, every material in your scene will now be VRay. Okay, now let's get right into figuring out how to create specific appearances to materials using the following scene here. If you want to follow along, open up the file called Material Test 02. In this scene, I have 3 primitive objects, each with different VRay materials applied using the standard settings. Well, VRay is all about GI, and GI is all about reflection. But reflection is only one of 2 possible things that can happen when light strikes a surface. When light strikes a surface, it can either be reflected off the object or sent through the object. And of course, it can be some combination of both of these as well. Now, if light gets reflected, it can be reflected at the exact same angle as it would be with a perfectly smooth surface, or it could be scattered during its reflection as it would be with a rough surface. If light goes through a surface, it's either refracted, i.e. bent, or it's scattered as it would be with translucent materials such as candle wax. I'm going to talk about all these possible scenarios in a little bit and how to simulate each, and I just want to start with the subject of reflection. So if I want to make an object reflect light, all I need to do is change the reflection color from pure black to something other than pure black. If I set the color to pure white, it will be 100% reflective. And when I render this, you can see that it is in fact a mirror-like object now. Notice that when I have the material 100% reflective, it doesn't matter what color I set in the diffuse color swatch. Since light is completely reflected, the material never has a chance to show you its diffuse color. Now, if I set the reflection color to gray, somewhere in between black and white, then the object will be partially reflected and it will partially show its diffuse color. Well, that's easy enough, but how do you control the smoothness of a material? A material's smoothness or roughness is determined by specular highlights. In fact, nothing about a material will give you a better indication of what the material is than with its specular highlights. And specular highlights in VRay materials are controlled through the reflection glossiness and highlight glossiness settings shown here. With a value of 1.0, VRay makes the material 100% glossy, so perfectly glossy in fact that the highlight is infinitely small and therefore invisible. Anything other than 1.0 results in a specular highlight, and the smaller the value, the larger the highlight and the rougher the material looks. And the reason the highlight becomes larger is the light is being scattered over a greater range of angles. So let's see this in action. If I change the reflection glossiness to 0.95 in render, I will actually see no highlight. Any idea why? Well, it's because the only source of illumination in the scene is environment light. So there's no acute light source to reflect. So I'm going to go ahead and quickly drop in an omni light. and I'm going to change the shadow type to VRay shadows, which we'll look at closely in Module 6. To position the highlight from this light so that I see it in a suitable location, I'll use the Place Highlight tool, which is a great way to move lights around in your scene. So now when I render, you can see a small highlight appear right here, and the entire surface of the object appears to have a rougher surface, and the reflections appear more blurred. Notice also how the rendering time went up a little bit. Let's rough up the surface a little bit more by bringing down or by changing the reflection glossiness to 0.75. Now the reflections are much more blurred and the surface appears rougher. So when you hear the term blurry reflections, this is what the term is referring to. It's not only a fantastic way to add realism to your materials, it's a great way to hide objects. And let me show you what I mean by this. In this image, you can see a slight blurring to the windows. This was useful in obscuring what lays inside the building, or what actually did not lay inside the building. The building was pretty much empty, and it also obscured what's being reflected. In both cases, I didn't want the viewer to be able to see inside the building clearly enough to see that there's not much in there, and I also didn't want the viewer to be able to see what was being reflected because it was a generic building and I didn't want to give any indication of what was actually going to be reflected in real life. I just needed something to be reflected rather than just a simple horizon line, which is never a good thing in visualizations. So these blurry reflections are a great quality to add to your scene if you need them. However, there's a major downside to their use. They can really increase your rendering time. The more blurry your reflections get, the longer it takes to render, and this is pretty much the case with any area of VRay or Max that applies a blurry effect to your scene. Now let's see how to control another quality of our reflections. Even though the sphere is being reflected, notice how grainy the blurry reflections are. Well, the quality of blurry reflections is controlled primarily by the subdivision value here, which works just like other subdivision values we've seen in other areas of VRay up to this point. So if I reduce this value to 1, as you'd probably expect, the quality of the blurry reflection suffers. And in fact, we see a very rough looking surface, almost like frosted glass. Now this may actually be a desirable side effect and a way to rough up the surface even more than by just reducing the reflection glossiness. The default value of 8 provides decent quality, but for really grainless reflections, you might want to try values up to 20. Okay, so far the changes we've made to the specular highlights on the sphere have affected the entire sphere. But what do I do if I only want to affect the blurring of the sphere and not the highlight? To do this, simply unlock the reflection glossiness and the highlight glossiness using the toggle shown here, and change the value of one independently of the other. So when I unlock the two, the reflection glossiness is automatically kept at 0.75 and the highlight glossiness is restored to its default value of 1.0. What these two settings now mean is that while the entire surface of the material wants to be blurred, the highlight itself will not be blurred because its glossiness value is 1.0. There are some very good reasons why you might want to have this kind of control, and let's look at one of them now. Well, one problem many users run into is not being able to control the highlights that naturally appear when they blur reflections on a surface. For example, in the following image, notice all the bright highlights that appear as dots on many of the surfaces of the kitchen appliances here. This is obviously a distracting side effect, and adding blurry reflections here might first be thought to be not possible. But rather than doing away with blurry reflections entirely, all you would need to do is unlock the reflection and highlight glossiness values and increase your highlight glossiness while leaving the reflection glossiness unchanged. And at some value, at some point, which is usually only determined by experimentation, you'll find that magic value where this nasty little side effect disappears, leaving you with a nice pleasing highlight. Of course, you could always just remove the highlight entirely by returning the highlight glossiness to 1.0, but these are all options that you have. And another example where you might want to separate these values is with the creation of water. If you just aren't getting the highlights to appear as you want them on the surface of the water because the highlights are too small, and you don't want to rough up the surface of your water anymore and make it look like sandpaper, simply leave your reflection glossiness in place and reduce the highlight glossiness so that the highlight spreads out more over the surface of the waves or the ripples in your water. While separating these values, you have to be careful not to go to extremes to the point that your materials are no longer believable. For example, if I place the reflection glossiness to 0.5 and place the highlight glossiness to 0.95, the result is clearly not realistic. Likewise, if I flip these two values, the result is equally unrealistic. And as you can see now, I have a smooth sphere with a rough specular highlight. This wouldn't be possible in the real world, but separating these values, like I've shown, is done usually more as a tool for hiding a problem like we saw with the kitchen image, or bringing out a look that would otherwise be difficult to show, as I mentioned with the water just a moment ago. Okay, I want to stop creating reflections and move on to another extremely important material characteristic, refraction. As I mentioned earlier, when light is not reflected off an object, the only other possible alternative is for it to go through the object. One of the ways it can go through an object is to be refracted or bent. And just like you enable reflections, refractions are enabled by adjusting the refraction color swatch shown here. So with a purely white color, you get 100% reflections. But what does this really mean? Well, all it means is that the light that goes into an object passes completely through the object. In the case of this sphere, the light I see right here is not reflected light coming from behind and bouncing off the sphere. It's light coming from behind the sphere towards the camera and being bent as it passes through the sphere. So by using a value between pure white and pure black, we get partial refractions as shown here. Now, as a side note, what do you think would happen if I made the refraction and reflection colors pure white, i.e. 100% reflective and 100% refractive? Let's see. So I'll change both to pure white and render, and this is what I get. The reason why you see a perfect mirror again is that even though the material is set to pure refractions, light never gets a chance to go through the object at all because it's completely reflected. So not only does the diffuse color have no effect on the material, none of the refraction settings will have any effect as well. Now what do you think would happen if I had 0% reflection and 100% refraction? Do you think the object will completely disappear? That's usually the first response that I get from students when I ask this question, but in fact it's both a right and wrong answer. Technically the object did disappear and the object is in fact completely transparent, but what we're left with is a faint but very noticeable bending of the light passing through the object. So if I want to see no trace of the object at all, it would stand to reason that the only way I can make this happen is to keep light from being bent so much. And the way I can do that is by using the index of refraction setting shown here. By using the default value of 1.6, watch what happens when I change it to 1.0. The object completely disappears. The object is still on my scene, but because the index of refraction is set to a value of 1.0, which corresponds to a perfect vacuum, light does not get a chance to bend at all as it passes through the object. If you want to simulate other refractive mediums, look at an index of refraction chart, such as the one available on the online VRay manual. There's a lot available on the internet, and you can look at a multitude of different mediums. Okay, so water, for example, has an index of refraction of 1.33, and when rendered, it changes the look of the sphere significantly. Now, the ability to simulate a substance like water is only as good as the physical object you're applying the material to, and in this case, a sphere is not appropriate for simulating water. When applied to a simple plane, the result would be much more realistic, as I'm going to demonstrate here. So I just quickly created a plane, I added a bump map to it, and that's about it. And using the index of refraction and positioning the light just so, I can get a pretty realistic look to my water just when it's applied to a simple plane object as shown here. Well, there's still a lot more to cover within materials, so let's push on and see how far we can get in a short amount of time. The next thing I want to talk about is Fresnel reflections. This type of reflection changes based on the viewing angle. For views perpendicular to a surface, reflections will be minimized, and for views parallel to a surface, reflections will be maximized. This type of reflection occurs in some objects in nature, and when used in VRay can add some really nice realism and some nice depth. Let's see this. So again, I have my sphere that renders with the same type of reflections, and now I'm going to enable Fresnel reflections, and when I do, notice how my sample slot changes immediately in appearance. Let's see what's going on here. If I render the sphere with the default Fresnel settings, the result is a much different look. If you look closely, you can see that the reflections in the center of the sphere are not as strong as the reflections towards the edge of the sphere, where the viewing angle is more parallel with the faces along the edge. Now, the strength of this effect is controlled through an index of refraction value, just like we controlled refraction strength. In fact, by default, the strength of Fresnel reflections is controlled by the very same index of refraction value we've been using, and that's because of this lock here. When unlocked, you see a new index of refraction value enabled, and now Fresnel reflections are controlled right here. So to change the strength of the Fresnel effect, all I need to do is change this value. If I reduce the value, you can see that the strength of reflections everywhere is reduced. In fact, I can keep reducing it to the point that only reflections along the edge of the sphere are visible. Finally, if I reach a value of 1.0, there's no more reflections at all, and I can also go in the opposite extreme. A value of 2.0 gives me strong reflections everywhere, but if I keep increasing the Fresnel effect above this point, or the index of refraction above this point, you can see that the reflections are getting so strong everywhere that I'm starting to lose my diffuse color and totally losing the Fresnel effect. In fact, I can continue to make the reflections so strong that the diffuse color totally disappears and my material returns to a perfectly reflective mirror, which finally happens when the Fresnel is set to 100, or the index of refraction. My point in demonstrating these ridiculous values is that Fresnel effects really only work when you use a value of greater than 1.0 and less than 2.0. If you do, this is really a wonderful way to add a touch of realism to certain types of objects in your scene. Next, I want to talk about another quality that VRay materials possess, and that's the max depth value. The max depth value specifies the maximum number of times that VRay will allow light to reflect from one surface to another. Depending on the exact field of application you're using 3D for, you will probably need to change this value only rarely. To see its effects, I'll maximize reflections on the torus in the scene and render as is. Everything looks okay right now, but if you look close, you can see these thin black lines in certain areas. These areas are the areas in which light wanted to bounce more than 5 times, but instead of bouncing more than 5 times, VRay stopped the bouncing and replaced the pixels in question with the exit color that is shown in the exit color swatch, shown here, which by default is set to black. Now, 99% of the time, 5 bounces will probably be enough, but when it's not, you'll know. Like all areas of VRay, I suggest setting values low and working up high until you remove problems. Watch what happens when I bring the max depth value down to 1. Those thin black lines become large black lines. If I change my exit color to something other than black, you can see exactly what areas have problems, which is a useful technique when you have a higher max depth value and thinner lines of the exit color. Even at 5, the green color stands out quite nicely. Next, let's look at this feature here called fog color. This feature makes thicker areas of an object appear darker than thinner areas. So if I make one end of this box thinner than the other side using an edit mesh modifier, and I'm just going to thin up one side, and apply a fog to the material, when I render you can see that the thicker area of the object is in fact darker than the thinner area. This is not a feature I really use, but I wanted to explain it so that you aren't left wondering what it does, since it's right here in the thick of things. Okay, now let's apply another neat look to a material, translucency. If an object is translucent, the light that passes through it gets scattered, kind of like light gets scattered with blurry reflections. A great deal of materials in the real world work this way, and let's see this in action. So I'm going to make this torus material approximately 50% refractive, which will allow the light to pass through it, at least partially. And let's enable the hard option here. When I render, I get a really nice, neat candle wax look to my material. Now let's try the soft option. And this is why I like working with materials so much, because of the enormous ways that you can create neat effects and appearances to objects in your scene. And if you didn't already suspect, you can control even more the appearances of your materials using map channels. For example, if I apply a simple noise map to my translucency channel, as I'll do here, I get translucency that changes throughout the entire object according to the controls in the noise map. The last area of materials that I want to point out at this point is a feature that causes a great deal of confusion among VRay users, and that's reflection and refraction interpolation. What they do is simply speed up the process of calculating each of these blurry effects. And these two features are fairly advanced, but they're worthy of mentioning at this point because of the tremendous impact they can have on rendering times when they're used properly. One of these is actually fairly easy to use, and the other can be quite frustrating. Let's look at the easy one first, refraction interpolation. So I'm going to enable glossy refractions on the torus, which will simply make the light scatter as it goes through the object, much like it does with translucency. I'll start the rendering, but notice how slow it gets, how slow it goes once it gets past the GI calculations. I can significantly reduce the rendering time by enabling use interpolation, which is this option here. But using interpolation here is not as easy as just enabling an option. If I render as is, as you can see, it becomes clear that something is definitely not working right with interpolation. If you scroll down in the material editor, you can see a refraction and reflection interpolation rollout that controls the quality of these interpolations. If you use an irradiance map as the primary bounce engine, which I would suggest, and it's what I use most often, you're going to need to match the min and max rate in this rollout with the min and max rate with the irradiance map rollout. Otherwise, you're going to get undesirable effects or results. So if I just make the simple change of matching my min and max rate with that shown in the irradiance map rollout, which in this case is -4 and -3, when I render, you'll see a much different result. The blurry reflections, or I'm sorry, blurry refractions look normal and quite smooth, which is what I was going for. At this point, I can use the interpolation samples in the reflection interpolation rollout to control the smoothing of the blurry refractions, just like I did with the interpolation samples in the irradiance map rollout. And I can also use the subdivisions value under the refraction color to control the number of refraction samples and therefore the overall quality. Well, reflection interpolation works just like refraction interpolation, and the savings in rendering times are just as great. I'm going to set my reflection glossiness to 0.5 and render as is. With a highlight glossiness value of 0.5, I can expect very blurry reflections, and knowing that the smaller I make this value, the greater the rendering time, I can expect this value to take some time. And as you can see, it is in fact taking some time. So now I want to use interpolation, so I'm going to enable it just like I did with refraction, and I've set my min and max rate to be the same as the irradiance map values. When I render, notice how much faster the rendering goes. The results are amazing. When you use interpolation in refraction or refraction, you don't have quite so much control over the exact look of the blurriness, but the rendering time improvement speaks for itself. And as great as the drop in rendering time was, watch how I can drop it even more by reducing the subdivision setting. I'll take it from the default value of 8 to 4, and now the sphere renders in just a couple seconds without really any significant loss in quality. As I just mentioned, the more blurry the reflection or refraction, the greater the rendering time, and therefore the more practical it becomes to use these interpolation options. But not only is it more practical to use interpolation as the blurriness of a material increases, it's also easier to control the quality. With reflection glossiness values close to 1.0, you're far more likely to get splotchy results. And I can see this here when I increase this value. and the closer you get to 1.0, the more you're going to have to compensate with more interpolation samples and higher subdivision values. At some point, you'll be spending more time compensating for this drop in quality than you would if you had just not used interpolation altogether. The last thing I want to mention in this module is some of the great material-related resources available on the internet. There are numerous sites that provide a great deal of bitmap images for both sale and for free, but there aren't too many that actually provide the actual materials. Two that actually do, and two that I've used extensively in my scenes, is the VizMaster's VRay Architectural Material Collection and the materials found on www.vray-materials.com. The VizMaster's collection is actually a plugin for purchase, and it provides a nice collection of shaders that actually institute their own unique interface, which is quite easy to learn and easy to use. The second website, www.vray-materials.de, is a site where members donate their material creations for the benefit of other members. There are numerous different categories for material types, and each one has a large and ever-growing number of great materials to choose from. Simply click on the material type, check out the description if you want, and download the material library file and upload the material in Max. Well, with this, we've covered all the major points I wanted to point out with materials. And if you're wondering about some of the other features that weren't covered in this module, rest assured the important ones will be covered in later modules. For example, the effect shadows option and the VRay light material are both important features, and both will be covered in Module 6 on lighting. Let's briefly review the most important things that were discussed in this module. I started the discussion by comparing VRay materials to non-VRay materials, and I stated that on average, VRay materials render about 10 to 25% faster than non-VRay materials, and they also usually result in better quality. There are special situations when it would be beneficial to use non-VRay materials, such as in the creation of fake specular highlights. Next, we saw how you can convert an entire scene of materials to VRay materials with one command that takes just a few seconds to execute. The color swatches control the strength of reflections and refractions, and we saw that if light is completely reflected, the refraction settings are rendered inconsequential. To enable blurry reflections for the entire surface of an object, decrease the reflection glossiness from 1.0. To control the blurriness of the material's highlight separately from the blurriness of all other areas of the material, unlock the highlight glossiness and reduce its value separately from the reflection glossiness. To increase the smoothness of blurry reflections or refractions, increase the subdivision value for either one. To give a material a rougher appearance, just reduce the subdivision value. Next, you can use Fresnel reflections to provide a really nice, unique, and realistic look to specific types of materials such as car paint, and you can adjust the index of refraction to values above 1.0 and below 2.0. Anything else and the Fresnel effect is pretty much lost. Use reflection and refraction interpolation to tremendously reduce rendering times. Ensure that when you use an irradiance map, the min and max rate within their respective rollouts match the min and max rate used in the irradiance map, and increase the interpolation samples to smooth the reflections and the refractions. Well, that pretty much does it for this module on materials. Hopefully you have a better understanding of what's going on with each of these features we've covered, and hopefully you can increase the quality of your visualizations while saving some rendering time.